Morning, YouTubers. Got an interesting video for you guys today. Today's unofficial sponsor, by the way, V8 Juice. I know, it's all right. So anyways, we are going to do some aluminum stick welding. Now this is probably going to be a pretty quick video because I only got 3 rods with this pack. I bought it from the local Menards, thought that this had like, I don't know, 6 or 9 rods for the $7 or $10 or whatever this was, but nope, 3 rods. So definitely can't get much welding done with that. Here's a little sheet off of it. I kind of find it funny, you know, okay, aluminum trailers, ladders. I don't know about welding on ladders, but whatever. Hey, I'd probably do it if I had to, but probably not the smartest thing. Lawnmower decks. I don't remember aluminum lawnmower decks, whatever. Boats, canoes. But weld aluminum is easy as steel. We'll find out if that's the truth. And this can also be used for brazing. No expensive MIG or TIG needed. So there you go. I read on the instructions here, talks about how you have to have a DC power source, which doesn't surprise me. It doesn't work on AC. And then doesn't really say much other than down here it gives, it says run a drag angle in 80 to 130 amps on DC EP. Now I've ran aluminum welding rods before with stick to a fair amount of, I wouldn't say success, but it'll glue something together. I generally preheated, and I thought that all of these would require preheating the aluminum. So I'm gonna preheat the plate with a little torch before I go and actually try and weld it, because from what I remember, these things wet out better with a little bit of heat on it. Definitely isn't gonna make pretty welds, nowhere near what TIG will, but let's get into that and see what happens. So the smart among you that know a little bit about welding rods will know that this is what they call an unclassified spec rod. So it just says aluminum. There is no designation, like this isn't 4043, this isn't a 6013. Like there's no American Welding Society classification on here. So the actual strength and viability of this process is really an unknown. And not only that, it definitely isn't legal for code work. Like if you had to do an aluminum hull on, I don't know, a boat or piping, you wouldn't want to use this because this is not a classified known rod. And even the rod itself just says satisfaction guaranteed aluminum, which apparently the packaging says if I'm not happy with it, I can get a refund. So we'll see. I guess you guys will be the judge if it's worth getting a refund on this or not. So what I got here is a simple piece of 1/8 inch aluminum. I'm gonna run a bead on this for scrap and then look at the weld and get an idea of what's going on because I've never ran this particular one. Let me go grab a torch and just preheat this. I almost forgot. Just enough to get it a little warm. I mean, this table here is ice cold, so that's gonna pull a ton of the heat out of it. You can see all the condensation from the air in here. Plate's so cold, it's forming on there. Ooh, that's hot. All right, well, let's run the first bead and take a look at it. Don't forget to laugh here at how hard of a time I'm having to strike the arc. I know I did when I edited this. Definitely not easy. Wow, well, I would say that's a little bit hot. The molten puddle seemed like it was instantaneously about 2 inches long. Welded all the way through the back, and that's only at 120 amps. That's pretty wild. I couldn't get the arc struck, like no matter what I did, it wouldn't start. So, interesting. I'm gonna drop the amperage quite a bit. So they said 80 to 130, well I would say 120 is quite a bit too hot, so I'll go back to, we'll try 95. The flux on this stuff is just like I remember, where it's just super gummy. I mean, I can hear it crackling here, but it's just, if you look at that, let me bring it up here if I don't burn my hands. That's about the worst weld I've ever put down, I think. But the flux is, I don't know, it's like molten white chocolate, gummy. All right, let's see with a reduced setting of 95 if I can actually make something that looks like a bead. That's a little bit better. Kind of don't want to contaminate any brush I have. I'll have to look for a real old nasty one. You can just see it's like salt or something, all this nasty stuff. 95 amps, a lot better. So we went from, oh my God, what is that? To, wow, there's actually a halfway decent weld. Now let me clean it off a little bit better so we can see it. That doesn't really look that bad, and we have, bump the camera, we have some penetration out the back. So that's surprisingly not bad. Man, to weld at 130 amps, you'd almost need like a 3-inch thick piece of aluminum, because I can't believe how hot that was. All right, well, my machine, I don't have hot start turned on, and if you look at this, the start on this was really rough, and you can see it's colder there, and then for most of it, it was pretty good. I'm gonna just turn on hot start. I don't have any adjustments other than on or off for it, so I'm just gonna enable it to help us a little bit. This is really a tough rod from what I'm seeing here to strike the arc. It just doesn't wanna start. I'm just gonna finish up this rod off right here, get the most out of it. Didn't waste a millimeter of that guy. Wow. That rod burns off really fast, like you better get moving with that. So the plate was a little preheated again. Start, which was a little easier to start with the hot start enabled. Let me see if I can't. Yeah, it's gonna be a pain to get off. The puddle's a little squirrely on this, but you know what? That's better than I honestly would have expected. So let's try and weld an actual joint. I'm not gonna preheat the plates. Well, you know, I'm just gonna put a slight preheat on them. Since these are ice cold. I'm gonna weld half of this, I think, and then take a look at it. And if I need to, I'll adjust settings. I even tack that? Yeah, right. Man, this is something else. So the molten puddles on that's really tough to see what's even going on. There's so much flux. Let's take a look. I got some penetration out back. I better use the pliers with this. Far from good, but good from afar. Real good penetration. That's actually kind of impressive to put down that much metal. There's still some flux on there, but I mean, look at the reinforcement on this side, and then it blew right through the back and probably would have made a liquid hole if it wasn't for this heavy, thick plate. Tacking with this is almost impossible. It just wants, you pretty much have to get moving right away. Yeah, the burn off rate on this is like, as fast as you can shove it in, it's burning off. Let me run this. I don't know if you can hear that. The slag makes a very interesting sound. Turns from like ice cream and solidifies and crackles. Starting to get the hang of it a little bit. Don't mind that giant crater there. Oh, see if I can get that off. Doesn't matter. Got it to be pretty equal in width. Penetration wise, a little bit colder. Interesting. All right, well, let's do another joint. I'll take this, put it on here, and try and do a fillet weld with this. That ought to be interesting. Last rod. Hopefully I can get this right. This is definitely going to be interesting. Well, I had to put so much pressure on the rod because the arc gaps started getting so big, I ended up pushing the plate away. No penetration through the back or the bottom. I'm pretty sure I missed tying in on part of it, but I guess we'll find out on that. Well, a moment of truth. there's still a ton of flux on there, so the bead is somewhat hidden in there. Honestly, I gotta say, I'm kind of surprised. It's better than I would have expected, and honestly, it's better than I remember. The last time I used something like this, I didn't have too good of results. I would say that I was running a little bit on the cold side. I mean, I got no penetration on the back, nothing through the bottom. I could have upped the amperage a little bit. It's definitely welded. Hit the bottom plate a lot more than the top. I mean, if you look at that, it kind of sunk down. Yeah, that looks pretty bad. My rod angle is a little bit off, but I'll tell you what, like right about here, it started popping out of here, like just spitting. So I really crammed that rod in there, and then all of a sudden, it just welded perfect. Like the arc was stable. The problem was I was hitting more of the bottom plate than the top. I mean, it's fused in there. Yeah, definitely a challenge to run, and I'll tell you what, that flux, my God. Like it's just gummy, sticky. It's on everything around here now. Awesome. Let me let this cool down. We'll take a closer look. Oh, this little guy's still a little bit hot, but looks pretty rough, but honestly, better than I would have expected. I would say that this process is serviceable for like an in-field repair. I wouldn't want to be marketing this to customers, and I mean, I guess in a pinch, hey, it works. I have no idea if this stuff will work like overhead or vertical up. I have a sneaky suspicion, judging by the molten puddle, that you probably would want to run this in the flat or horizontal only. I don't see this welding uphill too well. The molten flux, I've never really ran a rod that runs like this. I mean, it's literally like almost twice the bead width. No matter what you do, it's running ahead of your arc. The molten pool looks like, I guess, like a depression around, like in the center of the flux that's like a more silver color rather than white. Very difficult to tell, and man, you gotta cram that rod in there. Like I started out on this piece over here to ran okay. Once I enabled the hot start, it really seemed to help it. So if you have hot start on your machine, that's huge. It seems to start way easier with the hot start. But I'll tell you what, like I've never seen a rod melt through that much metal. I barely clean that off. But you can see there is a weld on that one, but wow, talk about carrying some heat. So definitely 130 amps or 20, I wouldn't run that on anything short of probably like half-inch thick aluminum. Let me hold it up there for you to see a little better. It's welded. Pretty interesting. I wish I had more rods. Like I said, I thought it was like a 9-pack, but man, it's kind of a gyp to do, you know, only 3 rods in here for the $8-9 or $8 whatever it was. They'll definitely get you out of a pinch though. Out of curiosity, I'm just gonna hammer this flat with this BFH and we're gonna see if it holds. I would think if I bend it away from the root, maybe it will. I guess we'll find out. The real hot crack definitely didn't handle that. Lost a lot of its ductility, being that it was melted through like that. But if you see here, I mean, it flattened all the way out. It held, did not rip off of there. So had I not screwed that up with that super hot weld, it would have flattened out real nice. So wow, pretty impressed, honestly. In a pinch, it'll get you out of a jam. Just don't run it hot. All right. Well, thanks for watching. If you got any comments, questions, or if you've ever ran this stuff and have an opinion on it, feel free to share it down in the comment box. Till next time, thanks.